Okay, 3.1, solving quadratic equations. And there are two ways to really, two ways to solve them, as graphing and factoring. And I'm going to go ahead and go through the first process here with graphing and factoring using the same equation. So first thing, if we're going to solve it using graphing, we have to find the vertex and axis of symmetry. And we know the axis of symmetry is equal to x equals opposite of b over 2a. And we also should know standard form is y equals ax squared plus bx plus c. And in this case, a would be 1, b would be 2, and c would be -8. Okay, and so if I'm substituting the pieces in, negative b, or opposite of b, is opposite of 2 over 2 times 1, which in this case would be -2 over 1, or -1. So x equals -1 is our axis of symmetry. So if I were to go to x equals -1, I'm just going to go ahead and dash in that line. We also know that my vertex, or our vertex, is on that same line. The x value will be -1. They're always the same. So -1, -1 here. And to find the y value, I'm going to go ahead and substitute in -1 for x. So I get -1 squared plus 2 times -1 minus 8, or 1 minus 2 minus 8, or -1 minus 8, which is also known as -9. All right. And so I could graph this and plot my -1, -9. I can use patterns or plug in other values. If I put 1 in for x, I would get an output of -8. If I was to put 0 in for x, I'd get a y-intercept of -8. I could reflect that point. If I were to put 2 in or 1 in for x, I would get an output of -5. And if I were to put, say, 2 in for x, 2 times 2 is 4. 4 plus 2 times 4 is 8. So 4 plus 8 is 16 minus 8 is 8 there. So, excuse me, I think I misspoke there. Let's try that again. If I were to put 2 in for x, actually, let's show that one because that's a key point there. 2 squared plus 2 times 2 minus 8. So that would be 4 plus 4 minus 8. And that ends up giving us 0. So y would be 0. So when I have an input of 2, I have an output of 0. And that right there is a key point. And if I reflect that, that's going to be over here. That is what we're looking for when we're solving by graphing. Okay, we're looking for the x-intercepts. When you solve by graphing, you're looking for the x-intercept. So we have the x-intercept of 2, 0, and its reflection, -4, 0. Those are my solutions. Okay, so if I solve by graphing, we can call those x-intercepts. A lot of times, kind of all the different names, x-intercepts, roots is another term you're going to see, solutions. Okay, so all of those things tell us or ask for the same thing, where your graph crosses the x-axis. Okay, now if I was to factor this, it's actually a little faster. Y equals x squared plus 2x minus 8. Remember, factoring, you're substituting 0 in for y. Why are you doing that? Because notice over here, that's what you want. You want an x-intercept. You want when y is 0. So that's why we put 0 in for y. X squared plus 2x minus 8. You're saying, okay, well, if I factor that, two things that multiply to make -8 and add the +2. Remember, this is just my way of kind of keeping track of stuff. So two things that multiply to make the top and add to the bottom. That would be, in this case, -4 and +2. Well, that makes -8, but that doesn't add to 2. Well, let's try something else. Let's try to switch that up. How about if we go +4 and -2? Well, that gives me negative 8, and that, yep, that adds 2. Okay, so we have x plus 4, x minus 2. We don't really have to worry about, usually I tell you to divide by your a term, but when I divide by a, nothing happens there. So I end up with x plus 4 times x minus 2. This times this multiplies to make 0. That means if x plus 4 were to equal 0, we get one solution of x equals. Yeah, my PowerPoint's getting in the way there, so let's write it over here. If x plus 4 equals 0, that gives me a solution of x equals negative 4. And if x minus 2 equals 0, that gives me a solution of x equals 2. Those are my solutions, and remember, it was when my output was 0, and gives me the same thing that I had here. X equals negative 4, x equals 2, or 2, 0, and negative 4, 0. So two different ways to solve. You have your factoring and you have your graphing. I personally will go factoring if it factors, and I rarely use graphing. There are other methods we'll go through, but that's what it means when you're finding these values. It means your x-intercepts. Okay. So let's try using the square roots. You notice one of my names were roots. Well, here, if I'm looking at this and I'm trying to solve this equation, well, I notice I don't have a b term. If you're looking at ax squared plus bx plus c, okay, and that equals, let's say it equals 0 because we're always trying to find our x-intercepts. Well, I don't have a b term. I don't have a term where x is to the first power. I just have my x squared, so there's no b term here. Therefore, I can just get x by itself. I'll subtract 4, I get x squared equals 36. And then I'll take the square root. That's how I undo a squared. So when I take the square root, it means I'm taking the square root of both sides. And remember, anytime you impose a square root or you start a problem without that square root and at some point you put that square root in, you need to put plus and minus in front. Okay? I'll show you why here in a minute. When I take the root of x, that gives me 6. Well, I know that 6 times 6 is 36, but I also know that, negative 6 times 6. Negative times negative is positive. Negative 6 times 6 is 36. So the way we write that is just the way I did there, plus and minus 36. That means if I were to look at the graph of this, my graph would cross here at 6 and over here at negative 6. I know it opens up because x squared is positive. However, it really doesn't matter if you were to move that x squared over and it opened down. You could have a graph that looks like that, or you could have its reflection. Then they look something like that. Excuse me, but they both cross right there at 6 and negative 6. I know I didn't do a great job there, but that's really what's happening. Okay, so let's go ahead and take a look at this next graph or next equation here. So once again, no b term, so I'm going to add 2. Okay, we get 2x squared equals 8. Then we do a third division, divide by 2, divide by 2. So we get 1x squared is equal to 4. And then we take that root again. Remember, when we impose the root, you got to put plus and minus in front. So plus minus 4, which x then is equal to positive and negative 2. And remember, that would just mean it crosses the x-axis at negative 2 and positive 2. All right, I'm going to do one more here, and let me switch up the colors. In this case, you could multiply out the quadratic, which would be kind of a pain. I see a lot of students trying to distribute here. I wouldn't go that route. Notice I'm multiplying here, so I'm just going to divide by that 4. Okay, and that just cancels. So I'm now left with x minus 5 quantity squared. That's equal to 5. And now notice this is squared. Now if you multiply it out, you're going to have a pain on your hands. But since it's a squared right here, I could take the square root. And that root is going to cancel that square. So now I'd be left with x minus 5 And that's going to be equal to plus minus root 5. Now, it's not a perfect root. We'll put that plus minus. And then I'd have to add 5 over. So add 5 here, add 5 here. And notice that I can't add something that's outside of a root to something inside, so I just have to kind of put it up front here. So we write that 5 plus minus, and then we put our root 5. If you could simplify the radical, you'd do it, but in this case we can't, so that is my solution. And really that means I have two irrational solutions. I have the solution of x equals 5 plus root 5, and I have the solution of x equals 5 minus root 5. So two different answers, and we write it in compact form like that. Okay? All right, well, let's see. Let's try a story problem here. When an object is dropped from a height in feet, t seconds after it has been dropped, can be modeled by the equation h equals negative 16t squared plus h sub 0. H sub 0, by the way, is your initial height. Okay? H sub 0 equals the initial height, or the starting height of the object. That's a key piece of information. Okay, h represents your height after any time. The height in feet after it has been dropped. Okay, a brick is dropped from 200 feet. That is my h sub 0 in this problem. From a 200-foot bridge crossing a river. Write an equation that gives the height in feet of a brick t seconds, after t seconds. So I could say, well, that height is going to be equal to negative 16 t squared plus h sub 0. And in this case, h sub 0 becomes 200. So we substitute that 200 in there, and there's my equation. How long does it take the brick to hit the water? In other words, if we want it to hit the water, that means its height will be now at nothing. We'll be at ground level. So we're going to substitute 0 in for h, and we're going to solve. Well, we'll subtract 200 over, so we get negative 200 is equal to negative 16t squared. And then we'll divide by negative 16. So t squared will give us negative 200 divided by negative 16. All right, so if we do that, we actually get 12.5. And then we're going to take the square root of that. So time is going to be equal to, notice we'll have plus minus. You can't have a negative time, so really the negative, yes, so really we just want the positive time. And the square root of 12.5, well, that's in between 3 and 4 because square root of 9 is 3, square root of 16 is 4. So square root of 12.5 is in between 3 and 4. In fact, it's if you round it, it's 3.54. Oops, 3.54 is the approximate time. Okay, so it takes about 3.54 seconds to hit the water. All right, let me go ahead and circle that. Okay, find and interpret h of 2 and h of 3. Well, it's important to understand, I guess, what h sub 2 or h of 2 means. That means the height of the brick after 2 seconds. Remember, h of t is what you're dealing with here. And so when we say h of 2, that means height of the brick after 2 seconds and height of the brick after 3 seconds. So we're dealing with seconds here. So if I found h of 2, that would mean I'd have to take my function and I'd have to put 2 in for t. So if I said, well, h of 2 is going to equal negative 16 times 2 squared plus 200. And then I want to subtract from that h of 3. So I have to calculate h of 2 and h of 3 first. So This will be 4 times negative 16, or negative 64 plus 200, which would give me a value of 138. And height, we're dealing with, oops, that's not 138. Sorry, that would be 136 feet. Okay, and then when we find h of 3, put that right here. That's going to be negative 16 times 3 squared plus 200. Okay, so negative 16 times 9. Well, negative 16 times 10 is negative 160. So if we take off a 16 there, we get to negative 146. Or 144, excuse me. Negative 144, and we add 200. And negative 144 plus 200 is, try to write that in there without actually affecting my, maybe I have to put it down here. Negative 144 plus 200 is 56. All right. So it says find and interpret h of 2 minus h of 3. Well, that means h of 2, and I'll write this over here, h of 2 minus h of 3, h of 2 being 136, minus h of 3, which is 56, gives me 136 minus 56 is 80. Okay, that means in 1 second, our brick traveled 80 feet. All right, in the 1 second, between 2 and 3. Okay. All right. Well, we have one more problem here. A local newspaper has 24,000 subscribers when it charges $10 per annual subscription. For each $1 increase in price, the newspaper loses about 1,000 subscribers. How much should the newspaper charge to maximize its annual revenue? The word maximize is huge here. What is the maximum? Well, the maximum, really, when you're dealing with a quadratic, a maximum, think about your parabola. It's when your parabola opens downward, it is the vertex. So when you're doing story problems with quadratics, you really want to key in on those terms maximum and a minimum, because those refer to your vertex. So it's a maximum there. Okay, so really I want to find the vertex, and first thing to understand is what this is actually saying. If I'm dealing with revenue, well, revenue, whoops, my eraser there. Revenue is equal to your number of subscribers times your price. That's going to give you your revenue. So for instance, we know we have a revenue based on 24,000 subscribers at a price of $10. So, I mean, technically right now our revenue is $240,000. That's not what they're asking us, but really that's kind of what we're doing here. So we're multiplying number of subscribers times the price. Well, what they tell us, let's go ahead and switch up the colors here. They tell us, well, if I look at my revenue and I'm going to change my subscribers. So I'm going to start at my 24,000, but I'm going to change the number of subscribers I have. I'm actually changing the subscribers based on the number of price increases. I'm going to lose 1,000 subscribers for every price increase of $1. So and I'm going to leave a space here because I'm going to add something to that. So my price that was starting at $10 is now going to increase by $1. And if I increase it $1, I lose 1,000 subscribers. If I increase it $2, I'd lose 2,000. If I increase it $3, I'd lose 3,000. So really, my revenue is going to be a function of the number of increases I make. And if I increase once, I lose 1,000. If I increase twice, I lose 2,000. So I'm going to put an N there. So N stands for the number of price increases. Number of $1, I guess, if you want to think of it that way. Price increases. Okay, and so R of N is equal to 24,000 minus 1,000 N plus 10 times 1N. Okay, and so if I kind of clean that up, it looks something like that. Not forget about what we're looking for. We're looking for the vertex of this. Okay, and the vertex is going to help us to find the maximum annual revenue, which is my Y value, and it's going to help me to find the number of, or the actual, the charge of the price. Okay, and so I'm going to go ahead and rewrite this one more time. I'm going to write this as negative 1,000 N plus 24,000 times, times N plus 10. And then I'm going to go ahead and factor out this 1,000 because I can solve this fairly easy if I can find the intercepts. So if I take out 1,000, in fact, negative 1,000 of this first quantity here, I'm left with N minus 24 and N plus 10. And notice I have a factored version now, which helps me because I can find the x-intercepts, or in this case the n-intercepts. So N minus 24 equals 0, which means N would be 24. So one of my intercepts is 24, and then I'd have N plus 10 equals 0, and N would be negative 10. So my solutions are 24 and negative 10. So if I were to kind of continue this picture here, I would have one of my solutions at negative 10 and the other one at 24. Which means my vertex is on the axis of symmetry, and that lies directly in between these reflections of each other. So if I were to find the axis of symmetry, that's equal to negative 10 plus 24, kind of the average of those 2 points, divided by 2. Negative 10 plus 24 is 14. 14 divided by 2 and is 7. So x equals 7. That is my axis of symmetry. And if x equals 7, what that means is if I substitute 7 into my equation, so my equation for R of N, so if I do R of 7 now, that's going to be 24,000 minus 1,000 times 7, and 10 plus 7. That's going to give me a revenue, and I'm not going to go ahead and do all the different steps here. Just a calculation of $289,000. Okay, and that's what they're asking. That means when x equals 7, my vertex is at 7, 289,000. Okay, so when I do 7 price increases, I'm going to have a revenue of $289,000, and that is my maximum revenue. And it says, how much should the newspaper charge to maximize the revenues? Well, that was after 7 price increases. So we've got the maximum revenue. Let's write that out. $289,000. How much should it charge? Well, you started at $10. You did 7 price increases. So let's write that over here. Switch that up in color here. So we'll go $10 plus N. And so 10 plus 7. This is, remember, equal to our price. Okay. 10 plus 7, or $17. So how much should it charge? Well, $17. At $17, you're going to have a maximum of $289,000. All right. One thing that could be confusing is someone looking at this, like, hold on, if my price is 17 and this is 7 over here, remember this picture is a picture of the revenue as a function of number of price increases, not the revenue as a function of the price. So this picture just dealt with the number of price increases. We use that and this piece right here to actually calculate our price. Okay, remember our price was our second quantity there. All right. Well, that's all I got. Good lucky.